Al2O3 and
Cr2O3.
Al2O3 and Cr2O3. Yeah. Al2O3 and Cr2O3. So the active material is chromium plus 3 ions. The active material is chromium plus 3 ions. Okay. Okay. Now, so let us see some of the fundamentals. Again, just in the previous class, you have seen some of the fundamentals, and then we went for ruby laser. So the ruby laser is nothing but a combination of aluminum oxide and chromium oxide, right? So the active component is the ruby rod, which is a combination of aluminum oxide and chromium oxide, right? So when a xenon lamp is given some potential, some flash will come from the xenon lamp, right? As soon as this flash comes, the chromium ions will activate and will process for the energy level transitions, right? So in the energy level transitions, the atoms will be excited to the excited state by the phenomena of absorption, and it reaches to the metastable state by releasing by not releasing any type of energy. Where we can have some atoms located at the metastable state, right? So that means at metastable state we can achieve a condition called population inversion, right? So when the condition of population inversion is attained at metastable state, the downward transition takes place below the ground state, right? So by releasing some sort of energy, right? So the energy associated with the ruby laser is expected to be 6,943 angstroms, right? So this is the energy that was released, and the energy that is released is not in a continuous process, but it is expected in terms of some pulse like formation, right? So the energy released, so that it is not a continuous form, rather it is a pulsed form, right? So we have seen some applications of ruby laser also in our previous class. Okay, now today we'll see what is another type of laser, that is the gas laser, right? So what are gas lasers? What are gas lasers? As I told you, what is a gas laser? 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 Gas laser is nothing but a helium neon laser, right? Gas laser is nothing but a helium neon laser. Okay, gas laser is nothing but helium neon laser. So we shall see the working principle of helium neon laser. Before that, let us see some more fundamentals. Let us see some more fundamentals related to metastable state and population inversion. See here, I am trying to share you some screen. See here. So this is what population inversion, as I told you, because this is an important mechanism for the lasing action to take place. That's why I am stressing so many times. Please listen carefully. Usually in a system, the number of atoms present in the ground state E1 is larger than the number of atoms present in the higher energy state. The process of making N2 greater than N1 is called population inversion, as I told you previously, right? So conditions for population inversion are the system should possess at least a pair of energy levels. That means it should have some energy levels that is pair. That is what already discussed previously. That is E1 energy level and other is E2 energy level, right? So separated by an energy equals to H nu. There should be a continuous supply of energy to the system such that the atoms must be raised continuously to the excited state. So the population inversion can be achieved by number of ways. That is, some of them are, one is the optical pumping, other is the electrical discharge, as I told you, inelastic collision of atoms, chemical reaction, and direct conversions. See here, if you can see the figure there, can you see the figure here? Can you see the figure here? Can you see the figure here? That is, one is the normal population, other is a population inversion. Normal population, we have one atom. Okay. one atom is jumped to the excited state, whereas in population inversion, the number of atoms in the excited states comes to the ground state. Can you see? Can you understand this figure, please? Yes?
Yes, sir.
Right. Let us go for metastable state, right? So what is metastable state? An excited state with relatively more lifetime, that is 10 power minus 3 seconds is called the metastable state. The necessary condition for population inversion is the presence of metastable state, as I told you, right? So this is one of the essential condition for the explanation of three-level system. Okay. So that is that is the phenomena here, right? So this all the process we have seen, the lasing action, right? Lasing action takes place like this. Okay, lasing action takes place between pumping, population, stimulation, emission of radiation, right? This is laser system. So as we have seen yesterday, so laser system is nothing but composed of some components of laser. That is one of the active medium, energy source, and optical cavity. And there we have seen some of the fundamental, some of the cases for the different type of laser. One of it is the ruby laser, where we have seen the combination of Al2O3 plus Cr2O3, right? And this is what we have seen the construction, and this is what the ruby laser. This is a ruby rod. I think we have discussed in the previous class, right? So this is a ruby laser. This is surrounded by some lamp. This lamp is connected to some power supply. When we on the power supply, a flash will come from this xenon lamp. As soon as this flash comes, the ruby rod gets heated up. So right, so the heated head and the laser beam will eject out, right? So when the flash emits, there will be a lot of heat generated. Okay, so the lot of heat is generated, right? When a lot of heat is generated, we can cool it. We need to cool the system. So that's why we place this particular system in a coolant, right? So this is what the ruby laser working principle we have seen yesterday. We have seen this is a ground state, and this is your excited states, and these excited states are 4F2 and 4F1 level, and the light that is ejecting is in the form of either green light or blue light, right? So the laser transition takes place from the metastable state to ground state, right? Metastable state to ground state, right? So this is what the lasing action that is taking place around 6943 angstroms or 694.3 nanometers. So this is what the discussion we have made in our previous classes. Okay, is that clear to all of you? Is it clear? Is it clear?
Yes, sir.
Okay. So this is what the applications and these are the drawbacks. And today we need to discuss what is helium neon laser, right? So helium neon laser is a one type of gas laser, right? Helium neon laser is nothing but a gas laser. One is ruby laser is a solid state laser, right? So ruby laser is a what type of laser? Ruby laser a laser and solid state laser antam then. Ruby laser is nothing but a solid state laser. Okay, and helium neon laser is a gas laser. So we have seen in our previous classes how many types of lasers we have seen. Have you seen or not? Chusama లేదా previous class lo?
Yes, sir.
In the previous class we have seen there are different types of lasers. Solid laser, that is ruby laser, ND by AG laser, and gas laser is carbon dioxide laser, and argon ion laser. Argon ion laser is nothing but helium neon laser. Okay, argon ion laser is nothing but helium neon laser. Okay, so this is what we call it as a gas laser. Okay, okay, clear? So helium neon laser is a one type of gas laser. Okay, so we shall see what are the how the mechanism takes place. This is a very important laser, and here, as I told you, in ruby laser we have spoken about three level schemes, that is a ground state, and an excited state, and the metastable state. But in case of helium neon laser, right? Right. So, so helium neon laser is a gas laser which works on the four level system, right? It works on the 4-level system, right? So let us see. So the best known and most fundamental, okay, is the screen shared? Is the screen shared to all of you? Screen share in and me andarki.
Yes, sir.
Yes, sir.
Okay. So the best known and most widely used helium neon laser operates at a wavelength of 6,328 angstroms. Okay, so earlier ruby laser were working on what type of wavelength? It works on 6,943 angstroms, right? 6943 angstroms or 694.3 nanometers. So that was the wavelength operation of the wavelength of the ruby laser. But whereas ruby laser, of course, it is a solid state laser. Whereas if you use the gas lasers, in gas lasers, the wavelength that is activated, the wavelength that a helium gas laser can generate is around 632.8 nanometers or 6328 angstroms. Okay, so that too also in the electromagnetic spectrum, we can see the red part of the visible spectrum. Okay, so in the electromagnetic spectrum, we can see that it is at the red part of the visible spectrum, right? So basically this laser, a helium neon laser, was first developed in Bell Telephone Laboratories. Okay, where it was developed? It was developed in Bell Telephone Laboratories in 1962. So helium neon laser is a gaseous laser. Helium laser is a gaseous laser, and moreover, it is a continuous 4-level laser. It is a continuous 4-level laser. Whereas solid state laser, ruby laser, is nothing but the 3-level system. That is ruby laser is a 3-level system, whereas this gas laser or helium neon laser is a 4-level system. That means there are 4 states. What are those 4 states? One is the ground state. One is the ground state. Other is the excited state.
Metastable state.
See here, in 4-level system, we have 4 types, right? So we have 4 levels. That means 4 levels of energy. That is, one is the ground state, other is the excited state. Okay, so one is the E1, okay, and other is E2. So E2 is the excited state, higher energy state, and between E1 and E2 we have 2 more levels. We have 2 more levels. Okay, so let us take this as E3. Let us take it as E3 and this as E4. Okay, so E1, E2. What is E2 here? E2 ay level ammadi? What is E2?
Higher
What
energy
is it?
level.
E2 is the excited state. E2 is the excited state, and E1 is the lower energy state. And E3, E4 are considered to be the metastable states. E3, E4 are considered to be the metastable states, right? Let us see. Right? So that's why the active medium here, as we have seen the components of laser, when we have seen the components of laser, we have seen the fundamental component is the active medium, right? Active medium, and later the pumping. We have seen the components of laser chusam kadandi. The first component of laser is active medium, right? And second one is the pumping, and third one is the mirrors, and fourth one is nothing but the whole system is taking place in a resonator cavity or optical cavity. So these are the basic components of laser. So a laser తీసుకున్న ఈ components అయితే full fledged గా ఉండాలి, right? So in that scenario, here if you take this gas laser, that is helium neon laser, okay? If you take this helium neon laser, the active medium is helium and neon gases. Okay, the active medium is taken in the combination of helium and neon gases in the ratio of 10:1 respectively. So helium is taken as 10 times and neon is taken as 1 time. Okay, helium neon gases are taken in the ratio 10:1. So what are the atoms that are responsible for lasing action? The atoms that are responsible for lasing action are the neon atoms. Okay, neon atoms are responsible for lasing action. Whereas in ruby laser, what are the atoms that are responsible for lasing action? Ruby laser lo ఏ atoms responsible అయ్యండి lasing action కి? రూబీ లేజర్ లో చదివినప్పుడు what are the atoms that are responsible for ruby for lasing action? ఏ atoms responsible అండి? బాబా ఐఎమ్ ఆస్కింగ్ క్వశ్చన్. రూబీ లేజర్ చదివినప్పుడు లేజింగ్ యాక్షన్ జరగాలి అంటే ఓకే లేజింగ్ యాక్షన్ జరగాలి అంటే మనం what are the atoms responsible for lasing action? In ruby laser I'm asking. In helium neon gas laser, the neon atoms are responsible for lasing action antunam. Whereas in ruby laser lo ఏ atoms responsible అయినాయి lasing action?
Aluminium and chromium.
ఏంటమ్మా?
Chromium atom.
Very good.
Aluminium and chromium.
Aluminium కాదు.
Only chromium atoms.
Only chromium ions, Cr3+ ions. Okay, don't tell atoms. Okay, chromium 3+ ions are responsible for lasing action, right? Similarly, when we speak about the gaseous laser like helium neon is taken in the ratio of 10:1, right? And neon atoms are responsible for lasing action. Okay, సో ఈ ఆటమ్స్ అయాన్స్ ఎట్లా చేంజ్ అవుతాయి అనేది మనం కేసెస్ చూసుకున్నాం. ఓకే, సో అందుకని క్రోమియం ఆటమ్స్ అనే ముందు క్రోమియం +3+ అయాన్స్ అంటున్నాం. ఓకే, ఇక్కడ కూడా Ne+ అయాన్స్ అనాలి. ఇక్కడ Ne+ అయాన్స్ అని అనాలి, లేకపోతే క్రోమియం ఆటమ్స్ అనాలి, లేకపోతే క్రోమియం +3 అయాన్స్ అయినా అనాలి, రైట్? సో that is the difference. Okay, chromium 3+ ions are responsible for lasing action in case of solid state laser, that is ruby laser, and here neon atoms are responsible for lasing action. So the energy source, what is the energy source that is taken? The energy source is the 2 electrodes are fixed near the ends of the tube to pass electrical discharge through the gas. Okay, so a gaseous, so ఇది గ్యాస్ లేజర్ కదా. సో గ్యాస్ లేజర్ లో కాబట్టి, సో దిస్ ఇస్ ఎ గ్యాస్ లేజర్, 2 electrodes are fixed near the ends of the tube. Okay, near the ends of the tube to pass electrical discharge through the gas. So this is the energy source. అక్కడ ఎనర్జీ సోర్స్ ఏం తీసుకున్నాము? రూబీ లేజర్ లో ఒక రాడ్ తీసుకున్నాక Al2O3 + Cr2O3 అనే రాడ్ తీసుకున్నాక ఒక జినాన్ ల్యాంప్ ని ఏం చేసాము? దాని చుట్టూ వౌండ్ చేసాము. అర్థమవుతుందా? దాని చుట్టూ ఏం చేసాము? జినాన్ ల్యాంప్ ని వౌండ్ చేసాము. జినాన్ ల్యాంప్ వౌండ్ చేసిన తర్వాత ఆ జినాన్ ల్యాంప్ కి మనం కొంత పవర్ సప్లై ఇస్తే దాని నుంచి ఫ్లాష్ వచ్చింది. ఆ ఫ్లాష్ అనేది ఆప్టికల్ ఫ్లాష్, దట్ ఈస్ వాట్ ద పంపింగ్. అది పంప్ చేసాము. అర్థమవుతుందా అండి మీకు? అర్థమవుతుందా? సో ఆ పంపింగ్ చేస్తే దాని నుంచి ఆప్టికల్ ఫ్లాష్ అనేది పంపింగ్ మెకానిజం అయింది. ఇక్కడ ఏమవుతోంది? ఎలక్ట్రోడ్స్ ని ఫిక్స్ చేసి ది 2 electrodes fixed near the ends of the tube to pass electric discharge through the gas. Okay, ends of the tube to pass electrical discharge through the gas. Okay, so this is what is considered here. Okay, now if you let us see the construction. Helium neon laser consists of a long narrow cylindrical tube. See here. So let us see here. Can you see on the screen? Screen మీద కనపడుతుందా?
Yes, sir.
Right. So helium neon laser consists of a long narrow cylindrical tube. This is a long, narrow cylindrical tube. Right. Helium neon laser consists of a long, narrow cylindrical tube made up of fused quartz, of diameter around 2 to 8 millimeters and length around 10 to 100 centimeters. Right. So this is what the construct. This is what the helium neon wire rod is. Right. So it's a long tube. Right. So the tube is filled with helium and neon gases. In the ratio of this it is to be taken in the form of 10:1. Right. So the pressure of the mixture of gases inside the tube is nearly how much? Pressure ఎంత ఉండాలి? A mixture లో pressure ఎంత ఉండాలి అంటే it should be around nearly 1 mm of Hg. Okay, ఇంత pressure maintain చేయాలి ఆ తీసుకున్న gaseous mixture లో. Right? Two electrodes are fixed near the ends of the tube to pass electrical discharge through the gas. Right? So here we are putting one electrode. This is one electrode and this is other electrode. Right? So this is one electrode and this is other electrode. What is anode and other is cathode. Right? So two electrodes are fixed near the ends of the tube to pass electrical discharge through the gas. So two optical plane mirrors. Okay, so this is one plane mirror and this is one plane mirror. Two optical plane mirrors are fixed at the two ends of the tube. Okay, so as we know that when we spoke about the components of laser, we have seen one of the component is the active medium, other is the pumping mechanism. Right, so to pump the active medium, and other is the mirrors. Right, so in this case also the components, one of the mirror is fully silvered so that 100% reflection takes place, and other is partially silvered so that 1% of the light incident on it will be transmitted. So ఈ లేజర్ లో అన్ని యాక్టివ్ కాంపోనెంట్స్ అన్ని వచ్చాయండి. కాంపోనెంట్స్ అన్ని వచ్చాయా రాలేదా? ఒకటి యాక్టివ్ మీడియం వచ్చింది, ఇంకోటి క్యాథోడ్ యానోడ్ వచ్చాయి, ఇంకొకటి పంపింగ్ స్కీమ్ వచ్చింది, ఇంకొకటి రిఫ్లెక్టింగ్ మిర్రర్స్ వచ్చాయి. ఆల్ ద కాంపోనెంట్స్ ఇంక్లూడ్ అయినాయా లేదా? లేజర్ లోకి ఇంక్లూడ్ అయినాయా లేదా? అన్ని కాంపోనెంట్స్ వచ్చినాయి. ఫస్ట్ ఏంటి కాంపోనెంట్? యాక్టివ్ మీడియం పంప్ చేసే ఒక పంపింగ్ మెకానిజం. నెక్స్ట్ ఏమిటి? ఇంకో కాంపోనెంట్ మిర్రర్స్. ఓకే, మిర్రర్ ఒక కాంపోనెంట్. సో టోటల్ రెసనేటర్ క్యావిటీ. సో అట్లాగా అన్ని కాంపోనెంట్స్ మిక్స్ అయినాయి ఒకటి. So that is what I'm telling you again. Here we have helium neon laser consists of a long narrow cylindrical tube made of fused quartz of diameter around 2 to 8 millimeters and length around 10 to 100 centimeter construction. The mixture is taken here. Helium neon gas mixture. It is taken in the form of 10:1. Right. So the pressure is maintained as equal to the pressure of mercury 1 mm of Hg. And we have placed some electrodes so that electrical discharge, that means electrical discharge is a pumping mechanism here. So when the electrical discharge takes place, the pumping of the neon atoms takes place. That means neon atoms will convert to neon ions and will try to give some energy levels. Okay, we shall see how the energy transitions takes place. Right. So one of the mirrors is fully silvered so that 100% reflection takes place, and other end is partially silvered so that 1% of the light incident on it will be transmitted. రెండు అద్దాలు పెట్టాము, ఒకటి ఫుల్లీ ట్రాన్స్మిషన్, ఇంకోటి 100%, ఇంకోటి ఫుల్లీ ట్రాన్స్మిషన్, ఇంకోటి పార్షియల్ ట్రాన్స్మిషన్. సో ఆల్ ద యాక్టివ్ కాంపోనెంట్స్ ఆఫ్ లేజర్ ఆర్ ఇంక్లూడెడ్ ఇన్ దిస్ టైప్ ఆఫ్ హీలియం నియాన్ లేజర్ ఆల్సో. ఓకే, సో దిస్ ఈస్ వన్ ఆఫ్ ద కేస్. Okay, so that is what. So one of the mirrors is fully silvered so that 100% reflection takes place, and other is partially silvered so that 1% of the light incident on it will be transmitted. Right. So if you come to the working principle of laser, okay. Right. So if you come to working mechanism of the laser, see, lasing action is due to, as we told, what is the mechanism for the lasing action? Lasing action is due to the neon atoms, right? Lasing action is due to which atoms? Lasing action is due to which atoms?
Neon atoms.
Lasing action is due to the neon atoms. Helium is used for selective pumping of neon atoms to upper energy levels. Okay, helium is used. Okay, helium is used for selective pumping of neon atoms. So helium is used, remember carefully, here helium is used for selective pumping of neon atoms. Ante ikkada helium atoms are used, okay, to pump the neon atoms. Okay, helium is used for selective pumping of neon atoms to upper energy levels. So the ratio of helium neon is taken in the form of 10:1. 10:1. So lasing action is due to the neon atoms. Helium is used for selective pumping of neon atoms to upper energy levels. Right? When a discharge is passed through the gaseous mixture, when a discharge, okay, because we are given some anode here, one cathode here. When current is passed, right? So when a discharge is passed through the gaseous mixture, electrons are accelerated down the tube. Electrons are accelerated down the tube. So these accelerated electrons collide with the ground state helium atoms and then excite to two metastable states. So as I told you, why we are taking two states. As I told you earlier, I'll tell you the reason. The reason for taking the two metastable states, okay, the reason for taking two metastable states, that means this laser is comprising of 4-level system. One is a ground state and other is excited state. One is E1 and other is E2. And later we took the two metastable states as E3 and E4. So the reason behind taking the two metastable state is, see, the reason behind taking the two metastable states is these accelerated electrons collide with the ground state helium atoms and excite them to two metastable states, that is one is 2,1s and other is 2,3s. Right? So this is the reason why we need to take two metastable states. Right? So whereas in solid state laser like the ruby laser, we have taken only the one metastable state. Right? So because the energy transition takes place between the metastable state and the ground state. But whereas in case of gaseous laser like helium neon, right, where we took the combination as helium and neon as 10:1, we observe 4-level transitions. Why this 4-level transition? In the sense, the reason behind taking the 4-level transition is there are two metastable states, and the reason again for taking the two metastable state is when a discharge is passed through the gaseous mixture, electrons are accelerated down the tube. Okay, electrons are accelerated down the tube. So these accelerated electrons collide with the ground state helium atoms. So see the ground state helium atoms and excite them to two metastable states. So those two metastable states are 2,1s and other is 2,3s. Right. Now let us see the actual mechanism. Right. So the helium atoms in the metastable state 2,1s, the helium atoms in the metastable state 2,1s. Okay, so metastable state 2,1s collide with the neon atoms in the ground state and excite them to 3s level. Okay, so see here. See here. So this is your helium and this is your neon. Okay, so the helium atoms are excited. Helium atoms are excited. That is 2,3s1 and 2,3s1 and 2,1s0. Right. Okay. So the helium atoms in the metastable state 2,1s collide with the neon atoms in the ground state and excite them to 3s level. Okay. See here. I'll show you simultaneously. Can you see? Can you see now? Can you see on the screen?
Yes, sir.
Can you see the energy level diagram and helium neon laser working both simultaneously on one slide? Is it visible?
Yes, sir.
Yes, sir.
See here. If you see the helium atoms in the metastable state 2,1s, this is your element. This is your helium atom and this is neon. So helium is taken as 10 times and neon is taken as 1 time. So the helium atoms in the metastable state 2,1s collide with the neon atoms in the ground state, right? In the ground state, and excite them to 3s level, and excite them to where? 3s level. That means the neon atoms will try to excite them to 3s level. Similarly, the helium atoms in the metastable state 2,3s, okay, 2,3s, okay, collide with the neon atoms in the ground state and excite them to 2s energy level, okay, and excite them to 2s energy level. See here. So see, this is 2, 3. So this is exciting. This is what the helium atoms in the metastable state. This is your metastable state for helium atom. So the metastable state for helium atom is trying to collide. Okay, the helium atoms in the metastable state in the 2, 3s collide with the neon atoms in the ground state and excite them to 2s energy level. Okay, and excite them to 2s energy levels. During collisions, the helium atoms transfer their energy to neon atoms and come back to the ground state. Okay. Since 3s and 2s levels of neon atoms are metastable states, population inversion takes place at these levels. Okay. Any of them spontaneously emitted photon will trigger the laser action. So the excited neon atoms transmit to ground state in 3 different ways, leading to 3 layers at different wavelengths. They are transition from 3s to 3p level, giving rise to a wavelength of 3.39 micrometers, which lies in the infrared region. There it is lying in the visible region. Here it is lying in the region of infrared. Okay, so this is how the lasering action takes place. Did you understand? Did you follow this? Did you follow this?
Yes, sir.
Or is this figure clear or this is clear? Is clear ga unda? Ee figure clear ga unda? Edi easy gunta cheptanu.
This is only clear, sir.
Edi? Ide amma?
Yes, sir.
See, this is your helium atom and this is your neon atom. So the helium atoms in the metastable state, okay, 2, 1s collide with the neon atoms in the ground state. Okay, neon atoms in the ground state collide and excite them to 3s level. Ekkadiki veltayi 3s level. Okay, ikkada helium neon collision jarugutadi ikkada. Right. Similarly, the helium atoms in the metastable state collide with 2, 3s. Okay, 2, 3s. Okay, and collide with the neon atoms in the ground state and excite them to 2s energy level. Student, ikkadi nunchi ikkadiki metastable, ikkadi nunchi 3p level, 2p level. 3p and 2p are expected to be the metastable states. 3p and 2p are expected to be what of states? Metastable states. అర్థమవుతుందా ఇది?
Yes.
Okay, so that is what I'm telling you. The helium atoms in the metastable state collide with the neon atoms in the ground state and excite them to 3s level. Similarly, the helium atoms in the metastable state, okay, the helium atoms in the metastable state collide with the new neon atoms in the ground state and excite them to 2s energy level. So here they are exciting to 2s energy level. During collisions, during the helium neon collisions, the helium atom will transfer whole of its energy to the neon atoms and come back to the ground state. Okay, ante higher energy level lo helium atom anedi neon atom ki energy transfer chestadi. Okay, transfer chesi andukane kada హీలియం అనేది 10 టైమ్స్ తీసుకుంటున్నాం, నియాన్ అనేది 1 టైం తీసుకుంటున్నాం. హైయర్ ఎనర్జీలో 10 టైమ్స్ లో హీలియంలో కొంత ఎనర్జీ నియాన్ ఆటమ్ కి ట్రాన్స్ఫర్ చేస్తుంది. ఓకే, ఎనర్జీ ట్రాన్స్ఫర్ చేసి అది మళ్ళీ గ్రౌండ్ స్టేట్ కి వెళ్ళిపోతుంది. ఎవరు? హీలియం ఆటమ్, రైట్? సో అట్లాగా ప్రతి ప్రాసెస్ అనేది కంటిన్యూ అవుతూ ఉంటుంది. అందుకని 10 టైం తీసుకున్నాం. హైయర్ ఎనర్జీ లెవెల్కి వచ్చేసరికి హీలియం ఆటమ్ నియాన్ కి ఎనర్జీ ట్రాన్స్ఫర్ చేసి మళ్ళీ గ్రౌండ్ స్టేట్ కి వచ్చేస్తుంది. ఏది? హీలియం. అప్పుడు లేజింగ్ యాక్షన్ అనేది దేని వల్ల జరుగుతుంది? నియాన్ ఆటమ్ ద్వారా జరుగుతుంది. సో దట్స్ వాట్ డ్యూరింగ్ కొలిజన్ ద హీలియం ఆటమ్ ట్రాన్స్ఫర్స్ దేర్ ఎనర్జీ టు ద నియాన్ ఆటమ్స్ అండ్ కమ్ బ్యాక్ టు ది గ్రౌండ్ స్టేట్, రైట్? Since 3s and 2s levels of neon atoms are metastable states, population inversion takes place at these levels. right? Population inversion takes place at 3s and 2 levels, 3s and 2s levels. Any of them spontaneously emitted photon will trigger the lasing action. For 3s level atom on the this will give lasing action around 3.39 nanometers. But the atom which ఎక్కడి నుంచి ఈ 3s నుంచి 2p కి ఇచ్చే ట్రాన్సిషన్ ఏదైతే ఉందో, the transition of metastable state occurring between 3s to 2p will give the maximum lasing action. Okay, so that is around how much? It is around 6,000 angstroms, right? So that is what is we are writing. The excited neon atoms transits to the ground state in 3 different ways, leading to 3 lasers of different wavelengths. They are transition from 3s to 3p, okay, giving rise to a wavelength of 3.39 micrometers, which lies in the infrared region, and other is the transition from 3s to 2p, and other transition is from 2s to 2p. So 3s to 3p madhya jarige radiation, wavelength radiation is very less, that is 3.39 micrometers, which is not at all required for lasing action. Okay, కానీ మనకు జరగాల్సిన ట్రాన్సిషన్ ఎక్కడి నుంచి జరగాలి? It should take between 3s to 2p. So how much wavelength it should emitted? It should be emitted around 6,000 angstroms, that is 6328 millimeters. Okay, 6328, sorry, it is not millimeters, 6328 angstroms, right? So that much amount of wavelength has to be emitted from the region 3s level to 2p level. Okay, so from 2p level there is a fast radiative transition should takes place. Okay, is it clear? Is this clear? చూడండి బాబు, చూడండి, ఏమైనా డౌట్ ఉంటే క్లారిఫై చేస్తాను. వర్కింగ్ ప్రిన్సిపల్ ఆఫ్ లేజర్. హీలియం గ్రౌండ్ స్టేట్ నుంచి ఎగ్జాక్ట్ స్టేట్ లోకి వెళ్తుంది. ఎగ్జాక్టెడ్ స్టేట్ లోనే మీకు జరిగే ఎగ్జాక్టెడ్ స్టేట్ లోనే నియాన్ ఆటమ్స్ తోటి అవి కొలైడ్ అవుతాయి. ఎగ్జాక్టెడ్ స్టేట్ లోని నియాన్ ఆటమ్స్ తోటి కొలైడ్ అవుతాయి. అప్పటికి నియాన్ ఆటమ్స్ 1 రేషియో తీసుకున్నాం కాబట్టి దానికి ఎనర్జీ తక్కువ ఉంటుంది, రైట్? ఎనర్జీ తక్కువ ఉండడం వల్ల హీలియం అనేది ఎగ్జాక్టెడ్ స్టేట్ లోనే నియాన్తో కొలైడ్ అవుతాయి. కొలైడ్ అయినప్పుడు హీలియం కాస్త ఎనర్జీ కొంచెం ట్రాన్స్ఫర్ చేస్తుంది. ఎవరికి? నియాన్కి. నియాన్ ఆల్రెడీ ఎగ్జాక్టెడ్ స్టేట్ లో ఉన్నాయి కాబట్టి, ఎగ్జాక్టెడ్ స్టేట్ లో ఉన్నవి మనం మెటాస్టేబుల్ స్టేట్ కింద కన్సిడర్ చేసుకుంటున్నాం కాబట్టి, సో ట్రాన్సిషన్స్ అనేది 3s అండ్ 2p మధ్యన, 3s అండ్ 3p మధ్యన, అండ్ 2s అండ్ 2p మధ్యన జరుగుతాయి, రైట్? సో ఈ 4 లెవెల్ ట్రాన్సిషన్ జరుగుతాయి. ఈ 4 లెవెల్ ట్రాన్సిషన్ జరిగినప్పుడు ఏదైతే ట్రాన్సిషన్ ఎక్కువ వేవ్ లెంత్ ఆఫ్ ఎనర్జీ రిలీజ్ అవుతుందో ఆ యొక్క హై వేవ్ లెంత్ రిలీజ్ అయిన ఎనర్జీ ట్రాన్సిషన్ మనం కన్సిడర్ చేసుకుంటాం. అట్లాంటి ట్రాన్సిషన్ ఎక్కడ జరుగుతుంది అంటే ఇట్ ఈస్ బిట్వీన్ 3s ఇట్ ఈస్ బిట్వీన్ 3s అండ్ 2p, రైట్? సో 3s అండ్ 2p మధ్యన ఎనర్జీ రిలీజ్ అవుతుంది. ఎంత ఎనర్జీ రిలీజ్ అవుతుంది అంటే ఇట్ ఈస్ అరౌండ్ 632.8 నానోమీటర్స్ ఎనర్జీ రిలీజ్ అవుతుంది, రైట్? సో అంత ఎనర్జీ రిలీజ్ అవుతుంది కాబట్టి ఆ పర్టికులర్ ఎనర్జీ లెవెల్ ని మనం కన్సిడర్ చేస్తాం. ఓకే, సో దట్ ఈస్ వాట్ వి కన్సిడర్ ది మాక్సిమం లేజింగ్ యాక్షన్. సో ద లేజింగ్ యాక్షన్ is taking place for what type of atoms? Neon atoms, right? So this is what the working principle of helium neon laser. Is that clear? Is that clear to all of you?
Yes, sir.
Any doubt? Any doubt, Andy? Any doubt? ఇగో చూడండి, ఇంకా కావాలంటే ఇది ఈ ఫిగర్ ఒకసారి చూడండి. సో దిస్ ఈస్ హీలియం ఆటమ్, దిస్ ఈస్ నియాన్ ఆటమ్. ఓకే, సో హీలియం excitation due to collision with electrons. Okay, atoms colliding with electrons, they excite to F2 and F3. So F2 F3 దగ్గర ఏమవుతుంది? నియాన్ ఆటమ్స్ తోటి ఇక్కడ కొలిజన్ అవుతాయి. ఓకే, కొలిజన్ అయినప్పుడు ఇక్కడ నుంచి రిలీజ్ అయ్యే వేవ్ లెంత్ అంటే 3.39 మైక్రోమీటర్స్. E6 to E3 మధ్య జరిగే ట్రాన్సిషన్ ఎంత? 6328 ఆంగ్స్ట్రోమ్. E4 నుంచి E3 జరిగే ట్రాన్సిషన్ ఎంత? 1.15 మైక్రోమీటర్స్. అండ్ E3 నుంచి E2 మధ్య జరిగేది 0.63 మైక్రోమీటర్స్. ఓకే, స్పాంటేనియస్ ఎమిషన్. ఇక్కడ డీఎక్సైటేషన్ బై కొలిజన్. అంటే మీకు హీలియం నియాన్ లేజర్ లోని ట్రాన్సిషన్స్ అనేవి హయ్యర్ ఎనర్జీ ట్రాన్సిషన్స్ దగ్గరే జరుగుతుంది. హయ్యర్ ఎనర్జీ స్టేట్ దగ్గరే ట్రాన్సిషన్స్ ఆఫ్ ఎనర్జీ జరుగుతుంది. డౌన్వర్డ్కి వచ్చేసరికి మీకు ఎనర్జీ ఏమైనా ఉంటుందా బాబు? డౌన్వర్డ్కి వచ్చేసరికి ఏమైనా ఎనర్జీ రిలీజ్ వస్తుందా? డౌన్వర్డ్కి వచ్చినప్పుడు ఎనర్జీ ఏమైనా ఉంటుందా లేజర్కి? ఏం బాబు అర్థమవుతుందా చెప్పేది? డౌన్వర్డ్ ట్రాన్సిషన్స్ ఇక్కడే జరుగుతున్నాయి, ఈ పర్టికులర్ ఫీచర్స్ దగ్గరే. డౌన్వర్డ్ ట్రాన్సిషన్స్ మీకు ఇక్కడే జరుగుతున్నాయి. ఓకే, ఇక్కడే మీకు లేజింగ్ యాక్షన్ వస్తుంది. ఈ రీజియన్కి వచ్చేసరికి మీకు లేజింగ్ యాక్షన్ లేదు. అర్థమవుతుందా? ఓకే,
Yes, sir.
అది కూడా మీకు E6 నుంచి మీకు ఎక్కడికి వస్తుంది? E6 టు E3 మధ్యన మీకు మాక్సిమం ఎనర్జీ రిలీజ్ అవుతుంది. ఎంత రిలీజ్ అవుతుంది? 6328 యాంగ్స్టమ్స్. ఓకే, సో E6 టు E5 మధ్యన నో ట్రాన్సిషన్, వెరీ మచ్ ఎనర్జీ, వెరీ లెస్ ఎనర్జీ. ఓకే, వెరీ లెస్ ఎనర్జీ ఇట్ ఇస్ జనరేటింగ్ బిట్వీన్ E6 టు E5. రైట్, E6 టు E5 మధ్యన ట్రాన్సిషన్ ఎంత జరుగుతుంది? ఓన్లీ 3.39 మైక్రోమీటర్స్. మాక్సిమం ఎనర్జీ ఎక్కడ జరుగుతుంది? E6 టు E3 మధ్యన జరుగుతుంది. సో ఈ పర్టికులర్ ఎనర్జీ లెవెల్ దగ్గర రేడియేటివ్ ట్రాన్సిషన్స్ జరుగుతున్నాయి. కాబట్టి లేజింగ్ యాక్షన్ అనేది ఏ లెవెల్లో జరుగుతుంది అంటే E6 టు E3. ఓకే, హయ్యర్ ఎనర్జీ స్టేట్స్ లో నియాన్ ఆటమ్స్ E6 టు E3 మధ్యనే మీకు లేజింగ్ యాక్షన్ అనేది జరుగుతుంది. సో మిగతా స్టేట్స్ అన్ని ఏమవుతున్నాయి? ఇవన్నీ లోయెస్ట్ ఎనర్జీ స్టేట్స్ అయిపోతాయి. ఇవన్నీ ఏం స్టేట్స్ అయిపోతున్నాయి? ఇవన్నీ లోయర్ ఎనర్జీ స్టేట్స్ అయిపోతున్నాయి. దేనికి? నియాన్కి. ఓకే, సో హయ్యర్ ఎనర్జీకి వచ్చేసరికి ఎనర్జీ ఎక్స్చేంజ్ త్రూ అటామిక్ కొలిషన్స్. హయ్యర్ ఎనర్జీలో మీకు హీలియం ఆటమ్స్ ఈస్ ట్రాన్స్ఫరింగ్ ఎనర్జీ టు నియాన్ ఆటమ్స్. ఓకే, హయ్యర్ ఎనర్జీలోనే ఎందుకు హయ్యర్ ఎనర్జీ స్టేట్ లో రేడియేటివ్ ట్రాన్సిషన్ జరుగుతున్నాయి అంటే హీలియం అనేది 10 times తీసుకుంటున్నాం కాబట్టి దానికి ఎనర్జీ ఎగ్జైటేషన్ ఎక్కువ ఉంటుంది. ఎగ్జైటేషన్ ఎక్కువ ఉండడం వల్ల హయ్యర్ ఎనర్జీలోని మీకు ఈ రేడియేటివ్ ట్రాన్సిషన్స్ అనేవి జరుగుతున్నాయి. మీరు అడగాలి సార్ కింద ఎందుకు జరగట్లేదు అని. కింద హీలియం అనేవి హయ్యర్ ఎనర్జీ లెవెల్కి స్ప్రెడ్ అయినప్పుడు, ఎక్కడ హయ్యర్ ఎనర్జీ లెవెల్లో ఉన్నప్పుడే హయ్యర్ ఎనర్జీ లెవెల్లో ఎనర్జీ ట్రాన్స్ఫర్ జరుగుతోంది. దేని మధ్యన? హీలియం అండ్ నియాన్ మధ్యన. అర్థమవుతుందా? హై ఎనర్జీ స్టేట్ లోనే హీలియం ఈస్ గివింగ్ ఎనర్జీ టు నియాన్ ఆటమ్స్. కొలిషన్ జరుగుతుంది. హీలియం ఆటమ్స్ కొలియేట్స్ విత్ నియాన్ ఆటమ్స్. అర్థమవుతుందా బాబు? అటామిక్ కొలిషన్ అనేది హైయర్ ఎనర్జీలో జరుగుతుంది. అర్థమవుతుందా అని చెప్పేది? ఓకే, సో అందుకని మీకు ట్రాన్సిషన్స్ అనేవి హైయర్ ఎనర్జీ ట్రాన్సిషన్స్ లో జరుగుతున్నాయి. సో అలాంటిది 4 level ట్రాన్సిషన్ అన్నాం. ఓకే, that's why we are telling helium neon laser is a 4 level system. Okay, so this is what the cases we are trying to observe, right? Now if you come to the applications of helium neon laser, so helium neon laser is widely used in laboratories for all interferometric experiments. Okay, the applications are helium neon laser is widely used in laboratories for all interferometric experiments. Helium neon lasers are used in supermarket checkout counters to read barcodes. Okay, సో హీలియం లేజర్ బార్కోడ్స్ పెడతాం కదా, ఎప్పుడైనా మీరు ఎక్కడికైనా పోతే ఒక్కోసారి బార్కోడ్లు పెడతా ఉంటారు. సో దట్ ఈస్ వాట్ హీలియం నియాన్ లేజర్స్ ఆర్ యూజ్డ్ ఇన్ సూపర్ మార్కెట్ చెక్అవుట్ కౌంటర్స్ టు రీడ్ బార్కోడ్స్. హీలియం నియాన్ లేజర్ స్కానర్స్ ఆర్ యూజ్డ్ ఫర్ optical character recognition. Helium neon scanners are used for optical character recognition. Okay, the helium neon lasers are used by newspapers for reproducing transmitted photographs. So helium neon lasers are used by newspapers for reproducing the transmitted photographs. So helium neon laser is also used for metrology in surveying and as an alignment tool. It is used in guns for targeting. So it is used in guns for targeting. They are used in 3D recording of objects called holography. So these are some of the applications. Okay, so these are some of the applications we can use for helium neon laser. Helium neon laser is widely used in laboratories for interferometric experiment. Helium neon lasers are used in supermarket checkout counters to read barcodes. Helium neon scanners are used for optical character recognition. The helium neon lasers are used by newspapers for reproducing transmitted photographs and also used in metrology, in surveying and as an alignment tool. So it is also used in guns for targeting. They are used in 3D recording of objects called holography. right? If you come to the applications of laser, lasers are used in medicine, lasers are used in medicine they are used. So they are used in eye surgery, especially to attach the detached to attach and detach the retina. And lasers are used for treatments such as plastic surgery, skin injuries, and to remove moles, tattoos, and tumors developed in the skin tissue. Lasers are used in stomatology, the study of mouth and disease. So these are what some of the applications used in medicine. Okay, so laser radiation is sent through optical fiber to open the blocked artery region. Lasers are used to destroy kidney stones and gallblade stones. Lasers are used in cancer diagnosis and therapy. Lasers are used in blood loss, less surgery. Lasers are used to control hemorrhage. These are all the applications used in medicine. So they are using carbon dioxide laser, liver and lung treatment can be carried out, and lasers are used in endoscopes to detect the hidden parts, right? So laser Doppler velocimetry is used to measure the velocity of blood in blood cells. So some of more applications of lasers are used in communication purposes. Okay, so these are some of the applications. So lasers are used in optical fiber communications as light source to transmit audio, video signals and data to long distance without attenuation and distortion. And laser beam can be used for the communication between the earth and the moon or another satellites. So laser beams can also be used for underwater communication as laser radiation is not absorbed by water. Okay, so lasers are used in militaries. Okay, so focusing on high energetic laser beam for few seconds destroys aircraft, missiles, etc. So these rays are called the death rays, what we call it as. So the vital part of the enemy's blood can be operated by focusing a high convergent laser beam from a laser from laser gun. They're used as lidars, that is light detecting and ranging, used to estimate the size and shape of an object, distance object of our weapons. So they are used in computers. Right? That is what laser computer we tell laser printers. Okay, so like that. So they are used in thermonuclear fusion. Okay, nuclear fusion reaction can be initiated by concentrating a large amount of laser energy in a small volume. For example, in the fusion of deuterium and yttrium, irradiation with high energy laser beam develops a temperature of around 10 power 17 degrees centigrade, which is sufficient to initiate the nuclear fusion reaction. Right. So these are some of the applications. And if you go for some scientific research and all, so lasers in scientific research, laser beam can initiate chemical reactions to study the nature of chemical bonds and also to break the molecules. So lasers are used to estimate the size and shape of a biological cells such as erythrocytes, right? So and they are also used to find the size of the dust particles. Okay, so they are used in counting the isotopes in isotope separation on the atoms. They are used to count. Lasers are used to count the atoms in the isotope separations. So these are some of the chemical applications and some military applications, computers and all. These are some of the applications of laser. Okay, so no problem. So you can have the glance. See here, this is your laser. This is what the active medium. So here we have some Brewster's windows. So helium cathode. Okay, so you try to learn all this. Okay, any doubt? Any doubt?
No, sir.
Is it clear? ఓకే, థ్యాంక్ యూ. ఇంకా చదవండి. ఇంకా నిన్న పంపించాను మీకు మెయిల్ పెట్టాడా మీ సిఆర్ బాబు? పెట్టాను. చదువుకోండి ఇంకా దాంట్లో క్వశ్చన్స్ ఇంకా. ఓకే, సో ప్రాబ్లమ్స్, థియరీ క్వశ్చన్స్ అవన్నీ చదువుకోండి. ప్రాబ్లమ్స్ ఉన్నాయా దాంట్లో? ప్రాబ్లమ్స్ ఉన్నాయా బాబు?